Welcome to Ironman's DPF maintenance training for diesel mechanics. This training will give you the opportunity to learn all about diesel particulate filters and how to properly maintain them to keep your particulate filters and engines running at peak performance. In this training, we will be covering the following topics and important information that diesel mechanics need to know about the new particulate filters on their trucks. We'll start with the background and why DPFs are required, DPF 101 and what a retrofit is and how they function, the difference between DPF regeneration and DPF cleaning, compatibility tests and inspections to verify that an engine is retrofit worthy, DPF maintenance requirements, Ironman Durathon service, examples of bad filters, DPF considerations such as swapping and redesignation, and finally we'll touch on how to clear red light instances. To begin, we'll start off with the basics of diesel particulate filters and their background. The air pollution emitted by diesel engines contributes enormously to our nation's air quality problems and contribute to serious public health problems in the United States. Fortunately, there are several techniques and technologies designed to reduce diesel pollution from existing diesel trucks and buses. Using pollution control devices such as diesel particulate filters, better known as DPFs, is one way existing engines can be upgraded or retrofitted to pollute less. In the United States, under the Clean Air Act, all vehicle emissions are regulated by the United States Environmental Protection Agency, also known as EPA. The state of California has its own more stringent standards, which are regulated by the California Air Resources Board, also known as CARB. And other states have also adopted the CARB standards for vehicle emissions, including most of the Northeast and the West Coast. To continue with our DPF 101 basics, let's move on to what a DPF is and how they work.
In diesel retrofitting, a truck's old muffler is removed and replaced with a diesel emission control device. This device traps and burns smoke and harmful particulate matter and prevents them from being released into the air. You'll note that a small amount of ash is left over. This is normal.
A diesel particulate filter is a ceramic device that collects the particulate matter in the exhaust stream. Inside the DPF is a complex honeycomb structure made up of approximately 200 holes per square inch that catches the soot as it passes through. The high temperature of the exhaust heats the ceramic structure and allows the particles inside to break down or oxidize into less harmful components. In older pre-2007 vehicles with no DPFs, there is no filtration in the exhaust system, allowing heavy smoke, particulate matter, soot, and other pollutants to come out straight out of the tailpipes. However, a diesel-powered vehicle equipped with a properly functioning filter will emit no visible smoke from its exhaust pipe, providing complete exhaust filtration. Wall-flow diesel particulate filters usually remove 85% or more of the soot and other contaminants, and can at times attain soot removal efficiencies of close to 100%. And how does it work? The honeycomb ceramic structure inside the DPF is designed to filter the exhaust gases while minimizing flow. By forcing the exhaust gases through the walls between the channels of the DPF, the particulate matter is deposited on the walls, so reducing the amount of air pollution. There are three different types of materials coming into the DPF system. One is soot, the other is wear materials, and the third is ash. Soot is made up of unburned fuel and unburned oil. There are also wear materials coming into the system, such as guides, valves, rings, liners, and other materials inside the engine. The metal will deposit itself into the DPF filter, whereas before they would go into the muffler and straight out the tailpipe. In the old days, diagnosing a diesel engine was done simply by checking the exhaust smoke. But now, with the new particulate filters, engine diagnostics are necessary to diagnose the engine. A DPF will work properly as long as there are optimum engine conditions. If the engine is running at its factory standard, then there is the proper amount of CFM that comes through, and the filter is able to keep up with the amount of burn that is required. The ash that comes into the DPF comes from the oil. It is purposely deposited into the oil as a pH balance. Ash cannot be burned. It deposits itself into the filter and must be later removed through a specialized DPF cleaning machine. Now we'll talk about the difference between regeneration and DPF cleaning. What is regeneration? Regeneration is the process of burning off the soot accumulated inside the substrate. The soot is burned off by the DPF as the engine runs, or through an outside source, depending on the type of DPF filter installed, and whether it is an active or passive system. We will talk about these two types of systems in the next slides. You must know that regeneration does not remove the built-up ash inside the substrate. This will be done through a specialized cleaning. In a passive system, there is an inlet cone, a diesel oxidation catalyst, or DOC, which is where the heat is generated to burn off the soot efficiently as long as there is sufficient exhaust temperature. And then from that point, the DOC is a flow-through to the particulate filter where the ash and wear materials are deposited. A passive device will constantly regenerate itself while the vehicle runs its normal duty cycle. 1994 and newer engines are eligible for a passive device if your exhaust temperature gets high enough. But municipalities, for example, the majority of the time will never get hot enough to qualify for this type of device. In an active device, there is an inlet cone, an outlet cone, a catalyzing agent, which is electrical or plug-in burner, and then there is the particulate filter. The regeneration in this type of device is not automatic. Regeneration occurs only once the operator or maintenance crew plugs in the device or pushes the regeneration button. Regeneration can occur once a day, once a week, etc., depending on how well the engine is running. Active devices must be regenerated while the vehicle is parked and the engine is turned off. Typically, regeneration is done at the end of the shift. Over a period of time, the ash deposited in the filter will cause excessive back pressure. Excessive back pressure will reduce the fuel economy due to loss of horsepower and create adverse conditions in the DPF in the engine. To remove the ash, a substrate cleaning is required, typically on a yearly basis, via an external specialized cleaning machine. In summary, it is important to know that regeneration only removes the soot, not built-up ash. DPF cleaning is required for that, and failure to do so may result in damage or failure to the engine, exhaust system, or DPF. By taking proactive action with your DPF cleaning service, you will avoid irreversible and costly damage to your DPF substrates, as well as safeguard the manufacturer warranty on your device. We will get into more detail regarding the cleaning process and our Durathon service in future slides.